Occurrence. Hydrogen is the most abundant element in the universe. It is the main stellar and interstellar constituent. About 70% of the total mass of the universe is made up of hydrogen. The outer atmosphere of the Sun consists largely of hydrogen. It is also the major constituent of the giant planets Jupiter and Saturn. Gaseous hydrogen occurs in the Earth's atmosphere in relatively small amounts due to its light nature, only 0.15% by mass. Hydrogen frequently appears combined with other elements. In the combined form, it constitutes 15.4% of the Earth's crust and the oceans. With oxygen, it forms water, the most abundant substance under Earth's surface and principal constituent of animal and vegetable tissues. Oxygen, hydrogen, and carbon are the base for all organic molecules that occur in plant and animal tissues, carbohydrates, proteins, hydrocarbons, and many other compounds. Isotopes of hydrogen. As we know, the isotopes differ from one another with respect of the presence of neutrons in the nucleus. Hydrogen has three isotopes: protium 1H1, deuterium 2H1 or D, tritium 3H1 or T. The most common form of hydrogen, protium, has no neutron in its nucleus. Deuterium, which is also known as heavy hydrogen, has one neutron, and tritium has two neutrons in the nucleus. An American scientist, Harold C. Urey, got the Nobel Prize in 1934 for separating hydrogen isotope of mass number 2 by physical method. The most common form is protium. Terrestrial hydrogen contains 0.0156% of deuterium. This mostly exists in the form of Hd. The abundance of tritium is about 1 atom per 10 raised to 18 atoms of protium. Only tritium among these isotopes is radioactive and emits low-energy beta particles. Different atomic and physical properties of hydrogen are summarized here in this table. The isotopes have the same electronic configuration, which is dependent only on the number of electrons or protons. Also, chemical properties of the isotopes are mostly the same for the same reason. Due to the difference in the enthalpy of bond dissociation for these isotopes, their rates of reactions vary. However, due to their large mass difference, these isotopes vary considerably in physical properties.